Good day everyone. We are the group Agrineers here to present a tutorial video about WeBot software. I'm Nathaniel and Pablo here to give you information about WeBot's platform. First, WeBots is an open source and multi-platform desktop application wherein it is used to simulate robots. The user can simulate an environment based on the objective, and there are multiple programming languages that can be used to program the robot. The following programming language that can be used are C, C++, Java, Python, and MATLAB. Lastly, there is existing projects where the user can study it and use it as a reference for other projects. So I'm going to show you a sample of an existing project in WeBots. So here is one of the existing files in the WeBot software, which is named as most demo file.
I'm Sofia McCarthy, here to present the creation of our robot. So, in the creation of our robot, we start with choosing a base node as a robot because we want to make one. We then go into children, and in this part, we will make the base of the robot and define its shape. For the body, we customized its X, Y, and Z direction. Then in bonded objects, we use this ship, and in physics, we used physics. For the wheels, we proceed into children again and add a hinge joint to have a rotary or linear motion so that the hinge joints will have joint parameters. The joint parameters will have devices as rotational motors because we need to rotate our motor in order to have translation in robot, and at the endpoint to have a solid. Lastly, we proceed to add distance sensors for our robot.
Hi, I'm Joshua Albert Lopez, and here's to explain the overview of the slave and master. So, for the overview of the slave, we have defined a function named run underscore robot with parameter robot. What it contains is the times underscore step, which is required to run virtually, and the max speed of the motors. Then after that, the motors are declared as well. Motors are captured by the get device functions, which is set as the float and is defined with an initial velocity. And then for the sensors, this device is also used. Each sensor is then enabled after capturing the device. After this, the while loop is used to run. Here, IR val are appended for variable containing sensor in data. Max underscore speed is assigned for each wheel. The conditions are decided such that when the right sensor has greater value than the left sensor and the right sensor is equal to 1000, the right wheel is reversed while the left wheel is remain at constant velocity. Then the reverse happens in vice versa when the left wheel left sensor is has greater value than the right sensor and the left sensor is also equal to 1000. And then here the values are printed to see response for the sensors. And then under here are the default speed sets for each motor. And then the overview for the master is then run through my underscore robot with parameter through the function run underscore robot. The interconnection will be further explained later.
Good day, everyone. I am Jamson Howell, and I will be discussing about how we set up this project. Here, we are showing you how the code would come together as one. We bots support multiple programming languages, but for this tutorial, we will be using Python. As you can see from the code that was written, we can see how the codes interconnect with each other. The slave and the master codes of the simulation as well as its connection to the environment. For this scenario, The master code will initiate an order for the whole bot to follow the black path. Only then the slave codes, which control the different parameters for the bot to move, would react to the commands of the master code, which the master code will react to the environment.
Hello, for simulation, I'm Denise de los Santos, 2%. Here we can see in the simulation, the robot can detect and follow the line drawn on the floor. The robot able to track the line because it uses IR sensor to sense. There are three of them, one from the left, middle, and right side, which was located beneath its base, pointing to the floor. The concept is related to light. The sensor works by detecting reflected light. By measuring the reflected light, it can detect the difference from light to dark. The behavior was the light surface reflect well while black surface reflect poorly. For that reason, it is able to difference between the line and the floor. The measurement indicates continuously by each of the sensor, which can be seen on the lower right of the window. The movement of the robot is controlled by adjusting the speed of the wheel. When the sensors are on the line of path, robot moves forward. If the left sensor moves away from the line, robot moves towards the right and so on. That's all. Thank you.
So that concludes our video tutorial on WeBots, presented by Agrineers. Thank you and God bless.